3.3 Truth Tables for Conditional and Biconditional. So now we're going to be doing truth tables, but for if-then and if and only if statements. So for this symbol right here, go ahead and tell yourself what it is. So when we have a single arrow, remember that is the conditional statement, meaning it's if-then. So if-then rules. The rules for if-then are true, true equals true. False, true equals true. False, false equals true. And true, false. True, false equals false. So if you were to remember one of these, it would be this one. Everything else is true. So you should remember is what makes it false, only true, false. So when you think of if-then, it's a conditional statement because we're saying if this happens, then this happens. So it's a condition, right? It has to be like, if it's cold, then it can snow, right? It can't snow when it's hot. It has to have that condition of being cold. So that's why true, if then true, that's always going to be true. If false, then true, because if I said something false, then it can be true. Like if I reverse what I just said, if it's snowing, or if it's cold, then it's snowing. Or, never mind, forget that. Okay. Then we have false, false, which is true, and true, false, which is our false. All right, we have our conditional statement of negation P, if then negation Q. So we have negation P, if then, negation Q. So we're going to do the negation first, then the Q, then we bring it together with the connective. Remember, the connective is always last. And 1 and 2 will give us 3. So let's do the opposite of P. So the opposite of the P they give us. So false, false, true, true. And then we need to do the opposite of Q. So the opposite of what they give us for Q. And remember, those are always going to be given to you. So we have true, opposite. False, true, false, true. Now we're going to bring it together. So when we bring it together, we're going to pay attention to the rules we have. So we have if false, then false. That's true. If false, then true, that is true. True, then false, that is false. True, then true, that is true. And remember, column 3, that's our answer column. An advert for Arco-Petrol makes the following claim. If you use Arco-Petrol, then you will not have engine knocking and you will enjoy driving. Translate the statement into symbolic form and construct a table. Alright, so let's bring this out. Let's figure out our P's, our Q's, and if we have another thing in R. So our first statement is the Arco-Petrol. We have our connective of if-then. Keep going. You will not have engine knocking. So remember, you always write the positive. So our Q is you will have engine knocking. Let's keep going. We have another connective word. We have and. We have another subject. You will enjoy driving. So let's go ahead and put this into symbols as we read along. So we have you will choose Arco-Petrol, which is P. So we have P, our connective if-then. You will not have engine knocking, so we do Q, but remember we have to negate it because of the not. We have another connective of and. You will enjoy driving, so we have Q. Let's see if we, my bad, R. Let's see if we need parentheses anywhere. And we do. See our comma? So that means our comma means parentheses. And we put the parentheses around Q and R because on the left side of the comma we have P, and then on the right side of the comma we have Q, R. So let's fill out our truth table. We have P, if then, parentheses, negation Q, and R. So I'm going to do the P first. Then I'm going to go inside the parentheses. So opposite sides of the connective. Now we need the connective. So 2 and 3 give us 4. And now I need to connect the left side to the right side. And that's going to be column 5. So all of the left side is P. That's all of the left side. The right side is brought together using the and connective. So 1 and 4 give us 5. Because all of the left side is P. And then together, all of the right side is the connective of and. Let's fill out our truth table. So P is just whatever P is. So true, 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 false, 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 false. Going to our next column, negation Q. So opposite of what they give us for Q. So false, false, true, true, false, false, true, true. Now just R, column 3, everything that is just R. Now we need to bring it together with our and. So if you don't remember and, go back to the previous section and pull up your and rules, okay? So we have false and true, that is false. False and false is false. True and true is true. True and false is false. False and true is false. False and false is false. True and true is true. So true and false is false. So you might have gathered that for and, just TT is true. So you need true and true for true. Our last column, we need to bring everything together. So 1 and 4 are going to give us 5. So if then, we're using the if then rules. So if then rules, TF is the only thing that is false. What I like to do if I have a lot of things going on, I will literally make it known. These are the only 2 columns I need to work on. I'll highlight it, I'll box it, I'll circle it. So we have true then false, which is true. Or sorry, I'm looking at the wrong one. True and false is false. True then false is false. True then true is true. True then false is false. False then false is true. False then false is true. False then true is true. False then false is true. And then remember, column 5 is the answer column. Now we're talking about biconditional statements. So biconditional statements are if and only if. So for if and only if, it's awesome. It actually has a really neat pattern that's easy to remember. Let me see if you can see it on your own. So remember how I told you if and only if, it's double F because it's double arrow. So double T and double F, my bad. Double T and double F are true. So that's how it's super easy to remember biconditional, because biconditional, bi means 2. So you have 2 arrows, and then you need 2 T's or 2 F's. We're given the statement. Let's go ahead and fill out our truth table. So we have negation P, if and only if. We have parentheses, negation Q, if then, negation or regular R. All right, the first column I would do is negation Q, or excuse me, negation P. Then we move on to the parentheses. So the parentheses, we would do negation Q, then R. Now we do our connective. So 2 and 3 give us 4. Last but not least is the final connective. So how do we get the final 5? The whole left side is 1. The right side is brought together with the connective. So 1 and 4 give us 5. Negation P, do opposite of P. Negation Q, do opposite of Q. R, we literally just do right R. All right, now we need to bring it together with if then. So remember, if then, the only thing that's false is TF. So F then T is true, F then F is true, T then T is true, T then F is false, F then T is true, F then F is true, T then T is true, T then F is false. Now we're going to bring it all together. So to bring it all together, we're going to be using column 1 and then column 4. That's what's going to give us 5. So for biconditional, for if and only if, we need doubles. We need a pair. So it needs to be TT or FF. So we have F then T is false. F then T is false. F then T is false. F then F is true. T then T is true. T is true. TT is true. TF is false. And again, column 5 is the answer column. Let's determine the truth value of the compound statement. Determine the truth value of negation P, if and only if Q, if then, negation Q, if and only if R. So it's telling us a few things. P is false, Q is true, and R is false. So it's like if we're looking at false, true, false, that. It's like if we were looking at that, but using this statement. So it's telling us it wants the opposite of P. So it wants negation, whatever P is false. If and only if, my bad, wow. There we go. If and only if we had Q, so Q is true. If then, negation Q, so negation, and then Q is true. If and only if R, which is false. So we're plugging in what P, Q, and R stand for. So whether it be F or T, it's telling us. And then we fill it in as we go. So we're just replacing the letter with its truth value, exactly the way it is. So let's simplify. Negation of F, that means true. Negation of T, that means false. Let's keep simplifying. So true if and only if true, that is true. if then. So now we have false if and only if false. That's true. So then our final answer is true, because true if then true is true. All right, determine the truth value of a compound statement. So this is like that Zac Efron question. If you have to Google a few things, that's okay, because in class, if this were a test in class, I would tell you, if you don't know something, please come to me. Like, if you don't know that Vanderbilt is in Tennessee, please come to me. If you don't know where Wake Forest University is, come to me. If you don't know where Syracuse is, you could have come to me in class. So if things like that you might not know, in class I would tell you, hey, come to me and I'll tell you where it is, okay? Because that's not your fault if you don't know that Vanderbilt is in Tennessee. That's okay. All right, so let's determine the truth value of each statement. So part A, the first statement is we have our connective if then. Our first piece is 15 is an even number. Is 15 an even number? Nope, it's not. It's false. And then, is 29 even? Nope, that's false. But when we simplify this statement, it's true. Logically, this is a sound statement, because what we're saying is we're making up the rules. So forget that you know anything about numbers. Pretend you are just a little kid and you're learning about numbers, and if I tell you this, 15 is an even number, so then 29 is an even number. That's a true statement, because we're saying odd numbers are actually even. I know it's a mind F, but logically speaking, this is a sound statement. Alrighty, part B. So we have our first statement, Vanderbilt University is in Tennessee. That's actually a true statement. It is in Tennessee. Vanderbilt is in Tennessee. We have a connective of and. Oop, I always do that. And Wake Forest University is in Alaska. It's not. I don't know where it is. I can't remember, but I know it's not in Alaska. You can look it up real quick, but it's not in Alaska. And then we have a comma, right? What does the comma mean? Parentheses. We have a connective, if and only if. Syracuse is in Alabama. It is not. It's in New York. So that's false. Let's simplify now. So true and false, that is false. So false, if and only if false, is true. So this is a true, logically sound statement. Vanderbilt University is in Tennessee and Wake Forest is Alaska, if and only if Syracuse University is in Alabama. Okie dokie, let's move on to our next example. Example 6. So the graph represents the student population by age group in 2013 of State College of Florida. Use this graph to determine the truth value of the following compound statements. Let's just break it down as we go along. So 44% of the population is younger than 20. Let's look. So younger than 20, 44%, that is true. We have a connective of or. 38% of the population is 20 to 29, so 20 to 29 is right here. It's 41%, not 38%, so that's false. We have a comma, so you know what that comma means. We have parentheses. We have a connective of than. Next, 8% of the population is 30 to 39, so 30 to 39, 8%, that's true. Let's simplify. So true or false is true. If then true. So this is a true statement. Self-contradiction is a compound statement that is always false. When every truth value in the answer column of the truth table is false, then the statement is a self-contradiction. So what that means is when the answer column is all false. When it's all false, you have a self-contradiction. Meaning no matter how you spin it, you are contradicting yourself. You're full of it. That's what that means. All right, so let's construct a truth table. You're probably like, I have 1, 2, 3, 4, 5, 6, 7 pieces, but you only gave me 5 boxes, because I'm going to show you that we can start to condense it a little bit. So I'm going to condense all of that all into one because there's no negations, and I'm just going to be using the truth values for the rules. So we have P, if and only if, Q. We have our connective, and. Since we do have a negation here, I always break that up because I can't keep track of a negation in my head. So I need to have it listed out. So we have parentheses, P, if and only if, negation Q. So I'm going to do my first set first, then I'm going to do P second, negation Q third, the biconditional statement fourth, and then the connective fifth. So 2 and 3 give us 4, and 1 and 4 give us 5. You might be picking up on a pattern here. You're not wrong. There is a pattern here. All right, first we have P if and only if Q. So we're looking at P and Q, and we need doubles. So true, true is true. True, false is false. False, true is false. And then false, false is true. Now we're going to write P for exactly what it is. We need to do opposite Q. Bring it together with if and only if. So true, false is false. True, true is true. False, false is true. True, false, true is false. Now to bring it together, we're going to be looking at 1 and 4 to bring it together. And we're using and. So T and F is F. F and T is F. F and T is F. T and F is F. So you see how it's all F? That means that this is a self-contradiction. A good song and music video, actually, you should watch the music video, is about contradiction, and it's just funny. Green Day, Walking Contradictions, they're old stuff. Some of you weren't even born for that. But it's just a funny video on like contradiction, and it kind of like in a satirical way explains contradiction. So it's a fun, I mean, what else are you doing, right? All right, a tautology. That's how you say like T-A-W, but tautology is a statement that's always true. So it's the opposite of a self-contradiction. It's all true. Instead of doing another truth table, I just did it for you guys. When we did all of the truth table, so we had our statement P and Q, so I put that in its own column because there's no negations. Then we have P or R, no negation, so it gets its own column. So we do P and Q, so true, true, false, 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 false. Then P or R, we bring it together, and we get all true. Since the answer column is all true, it is a tautology, or also known as a logically true statement. An implication is a conditional statement that is a tautology. So remember, a conditional statement, that's this one, that's if-then. So it's the consequent will be true whenever the antecedent is true. So when you have an if-then statement, it's called an implication if it's a tautology. I'll say that again in another way. If-then statement, if it's all true, it's an implication. So it's a special tautology.